Hey everyone, this is Mrs. Snook with section 9.2, Quadratic Functions. And what we're going to do today is we're going to graph quadratic functions in the form of y equals ax squared plus bx plus c. And so that would look something like this. So y equals, say, x squared plus 9x plus 5. By the time we're done today, you should be able to graph a function like that. Here's our first problem. You throw a ball straight up into the air and catch it at the same height that you released it. The parabola at the right shows the height h of the ball in feet after t seconds. What is the total distance the ball travels? And then for how long does the ball travel up? And we're going to explain our reasoning. So first of all, the total distance, well, it started at 0, at height 0. It went up to, looks like, let's see, 0, 8, 12. This looks like that's about 20. So it went from 0 up to 20. And then it goes back down from 20 back down to 0. So it went 20 feet up and then 20 feet down, so the total distance is 20 plus 20, or 40 feet. And then it says, how long does the ball travel up? Well, so on our left side here, this is where the ball is going up, and when it gets to the top here, it turns around and goes back down. And this is the vertex at the top. So, looks like at 1 second, that's when it's going to change direction, so it goes up for 1 second. Next, take a look at these graphs here. Our first one on the left is 2x squared plus 2x. And this blue dashed line is called the axis of symmetry, and it's going right through the vertex. So right there's your vertex. And what the axis of symmetry means is on both sides of that axis, the parabola has the same y value. So it's kind of like a mirror. Okay, and then if I was to take a point here, see here and here, both those 2 points, they would have the same y value. And then now look at 2x squared plus 4x. Now this axis of symmetry, our mirror has shifted. It was at about 1. Now it's shifted over, and it looks like it's at about, let's say 2. And then look at the third one. Now we have 2x squared plus 6x. The only difference in these is the b value has changed. And each time it changes, our axis of symmetry changes. Now there is an equation that we can use, which is the axis of symmetry is going to be negative b over 2a. So if I go into my equation, so my first one, I have 2x squared plus 2x. We have b equals 2 and a equals 2. So my axis of symmetry is going to be x equals negative 2 over 2 times 2, so x equals negative 1/2. We can do the same thing for the other 2 graphs, and then we'll get where those axes of symmetries are. So here's our key concept. If you have ax squared plus bx plus c, and you're going to use these coefficients for a, b, and c, you can calculate the location of the axis of symmetry by using x equals negative b over 2a. The other thing is your vertex is going to be on that axis of symmetry. And the only way that happens is if the x-coordinate of the vertex is negative b over 2a. So let's do an example where we're going to graph. I'm going to graph x squared minus 6x plus 4. My first step is to find the axis of symmetry. So a equals 1, because I have an invisible 1 in front of x squared. B equals negative 6. And C, I don't really need that, but it equals 4. So my axis of symmetry is going to be x equals negative b over 2a. So then plug that in. Negative of negative 6 over 2 times 1. That's going to give me 3. So my axis of symmetry is going to go through x equals 3. And while I'm at it, let's go ahead and get the y-coordinate because that will give me my vertex. So I'm going to plug in 3. And so y equals 3 squared minus 6 times 3 plus 4. And if you punch that into your calculator, you're going to get a negative 5. So that means our vertex is at the point 3, negative 5. And then it says find 2 other points on the graph, and then we're going to graph the vertex and the points that we found. So let's go ahead right here. Let's draw a graph. The vertex I found was at 3, negative 5. And that is also the axis of symmetry. So I'm going to sketch that in. So there's my axis of symmetry. Now I'm going to pick 2 more points to figure out. And I'm going to go ahead and do an XY table for that. One point that is super easy is x equals 0. So if I plug 0 into my equation, I'm going to get 0 squared minus 6 times 0 plus 4, and that's just 4. So I have a point at 0, 4. And then let's get one more point. You can use x equals 1 or x equals 2, whatever you like. I like 1 because, again, it's nice and easy. So I'm going to plug in 1 squared minus 6 times 1 plus 4. So 1 minus 6 plus 4, I get a negative 1. So there's my point. And now reflect those points over the axis of symmetry. So what this does for you is you have a nice little shortcut. I normally would ask you for 5 points, but you can get away with figuring out 3 of them and then reflect to get the others. So this point at 0, negative 1, I'm going to come over here. So this was 2 points away from the axis of symmetry, so I'm going 2 points this way and down 1. So there's my first reflected point. My second one was through 0, and that was 3 points away from my axis of symmetry. So over here, come across. There's that one. So here is our parabola, right like that. So find the vertex plus 2 more, and then reflect, and you'll have a total of 5 points. All right, try this one on your own. We're going to graph negative x squared plus 4x minus 2. I want you to pause your video, draw your graph, and then you can compare to mine. Here's the graph that I got. My axis of symmetry went through x equals 2. And my vertex was at the point 2, 2. Notice it's opening downward. And then I used 0 and 1 for my other 2 points, and then I just reflected them across. All right, part 2. Now we're going to use the vertical motion model. So during halftime at a basketball game, a slingshot launches t-shirts at the crowd. A t-shirt is launched with an initial upward velocity of 72 feet per second. The t-shirt is caught 35 feet above the court. How long will it take the t-shirt to reach its maximum height? What is the maximum height? And here we're given the function h equals negative 16t squared plus 72t plus 5. So we're going to use that function, and we're going to figure out how long it takes to reach its maximum height and what that maximum height is. Now, one thing I want to point out is that maximum height is where it's going to change direction. So that's going to happen at the vertex. So what we really want is the vertex. And our vertex is going to be TH. So my axis of symmetry, that's going to tell me the time t, and then I plug that in, that's going to give me the height h. So here goes. Get my axis of symmetry, so A equals negative 16, B equals 72, C equals 5. Our axis of symmetry is going to be t equals negative a, or negative b over 2a. So I'm going to get negative 72 over 2 times a negative 16. And when I punch that in my calculator, negative 72 divided by 72, I get 2.25. That's how long it takes to get to that maximum height. And then let's find that height. So I'm going to plug in that 2.25. I'm going to get negative 16 times 2.25 squared plus 72 times 2.25 plus 5. So go ahead and punch that in your calculator. And I got 86. So what this means is that t-shirt, as it's flying through the air, it's going to be 86 feet high, and it's going to take 2.2 seconds. And at that point, it's going to turn and start going back to the ground. You can also graph this on your calculator. And I went to a site called Desmos where I graphed this. And when you're graphing on your calculator, it only likes x's and y's. It doesn't like h and t. So on your calculator, what you want to do is you want to say y equals negative 16x squared plus 72x plus 5. And when you do that, it will make a graph that will look something like this. Right here is the vertex. And do you see? The y-coordinate of that vertex is at 86 feet. All right, that's it for today, everyone. Thank you for watching and have a great day.